we would do this one and say dividing fractions easiest, 5, flip the second and multiply, right? Multiplying by 4x cubed minus 8x squared over x plus 3, x plus 1. Now, when you then factor each piece? So I'm going to erase this really quick, and then, so to give myself room, and then right here, now we would say, okay, aren't we technically just multiplying straight across? So I'm going to throw parentheses around these. We're really just multiplying, and then I'm going to extend my line. Isn't that what we're really looking at here? Factor each piece. What does that piece become if you factor it? And then this piece, what do we do? No, we should be pulling out the greatest thing in common, so pull out 4x squared, left is. And then on bottom, so once again though, guys, this is all multiplication, isn't it? So we can divide any of these things out. What does this piece factor to be? And then that's already factored. So this is what we're looking at, right? Now, now we can divide out exact factors. We're not going to spend time today restricting values. We don't have time. We should be okay with that by now. Okay, so divide out exact factors. And then anything else? So what's left on top? 2 times, 2x squared times x minus 2, and on bottom, x plus 1. Questions? That's really how quick you should be at this point, for the most part. Okay, let's try another one. Now, you got to remember how to factor 2 perfect cubes. You have to remember that. Do you remember the cute little trick? Front times the front, front times the back, back times the back. Okay, go. So factoring this piece, you'll have to know this is the sum of 2 perfect cubes. So to factor, we'll use our little trick, cube root that, cube root that. So our front thing, I'm just factoring that piece. Our front thing's x, our back thing's 2, isn't it? So then we would say, okay, the front times the front is x squared. Then the front times the back. Back times the back. Then this sign is the same as this sign. The next sign is opposite of that. The ending sign is always plus. You need to know that. You need to know how to factor 2 perfect cubes. Then on bottom, okay, we just factored purple. I'm going to change colors. For this piece, we would pull out a x, and then left is minus 2x plus 4. Then we would check, does this quadratic factor, does this quadratic factor? Well, even if they didn't, are they going to end up dividing out? So I'm not going to keep going. They don't factor though. Just a reminder, they don't with perfect cubes. We would have 2 imaginary solutions. I'm not asking you for the solutions. I'm asking you to factor it and simplify. Now we would multiply by, what would we pull out here? Make sure that if there's a negative in front, it's not considered factored. So you're right. Pull out -4, divide by -4, divide by -4. So left is x minus 2. Correct? And then on bottom, so this line is technically connected, dang it. And then down here, what method of factoring? Grouping. Group these two. What would I pull out here? I'm going to do it over here, because I only want to put my final answer here. I pull out x squared, then left is 2x minus 3. What would I pull out here? -4, so divide by -4, divide by -4. So then left is 2x minus 3, so I can pull out 2x minus 3, and left is x squared minus 4. Does this keep factoring? X minus 2x plus 2, right? So that piece just became 2x minus 3 times x minus 2 times x plus 2. Now look at it. Isn't it factored completely? Yeah, and we've checked what multiplies to be 4 and adds up to be -2. Nothing. So it is factored completely. So now we can divide out exact factors. X plus 2 on top, any x plus 2s on bottom. We have x squared minus 2x plus 4 on top, any of those on bottom. -4 on top, anything to divide out with -4 on bottom. X minus 2 on top, and x minus 2 on bottom. So left on top was a -4, left on bottom was x and... Okay, make sure once again you know how to factor perfect cubes by grouping and so on. All the methods we've learned. Okay, awesome. Let's get to today's lesson then right away. So So what we're doing today is 2-3. We're going to be adding and subtracting rational expressions. Now this is different, and people start confusing it with multiplication and division, which is what we learned last time. So remember, when multiplying and dividing fractions, you do not need a common denominator. You multiply straight across, factor it out, and then divide out exact factors. Now what we're doing today is adding and subtracting fractions. If you add or subtract a fraction, you have to have a common denominator. So look right here. Now, and also when doing this, you want the least common denominator because then there'll be less simplification in the end. So everybody look at this example. 3/2 plus 4/3. With addition, we do need a common denominator. Let's find the least common denominator. So this one has a 2, this one has a 3. So won't we do 2 times 3? Our least common denominator is 6. So I'm going to make this 6. So I'm going to multiply by 3 over 3. I'm going to multiply by 2 over 2. Multiply straight across. I get 9/6 plus 8/6. Now when I'm combining these, because they have a common denominator, I'm still going to just add straight across, but you don't add the bottoms, right? 9/6 plus 8/6 is how many 6? 17/6. Okay, awesome. Now look down here. Don't just take and multiply by each other's denominator. What you're going to do is find the least common denominator. What is the least common denominator of 2 and 4? 4. So my least common denominator is 4. This one's already a 4. It doesn't need fixing. 2 times 2. So then that would be 6/4 plus 1/4 is 7/4. Now understand, if you would have found a denominator that was not the least common denominator, you still would have got the right answer. It's just you would have had to simplify it more in the end. You're not going to want to have to do that when we get to harder stuff. So always find the least common denominator. Okay, everybody look. Do not start confusing multiplication versus addition. With this one, we don't need a common denominator. Can't we just multiply straight across? And we do multiply the top and bottom, right? So this would be 8 over 9. But down here, addition, you don't combine your denominator. So people start switching this backwards in their head. That's why I'm going over it. So this one would be 8/3. See what I just did? I just multiplied it because that's so easy to do, especially when you get going quick. So good point. 6/3, that's testing you. And now we can simplify it to be 2. Okay, we'll pretend. Okay, here we go. Number 1. 1a plus 1a. Do we have a least common denominator already? Yep, so add straight across. We have 2 over a. Then you say, does my answer simplify? Nope. So we're done. Starting out with the basics. Number 2 on the worksheet. 11 over 2y plus 27 over 2i. We already have a common denominator, so what do I get? 38 over 2y. You say that's my answer, but now I need to simplify. We simplify by factoring and then dividing out exact factors. So with this one, isn't it just 19? 19 over 1, so our answer would be 19 over y. So your last step is to simplify, just similar to multiplication and division. Okay, looking at these two. Don't we already have a common denominator? So we can add straight across. So we have m plus 4 over m plus 4. You say, that's my answer. Now I need to simplify. Yep, they both divide out to be 1. Exact factors divide out to be 1. We're starting out with the basics. I know, basics are pretty basic. Okay, number 4. This is why I put a red flag up, because if you're going to miss a problem, it's most likely going to be a subtraction problem, because here's why. We're subtracting all this stuff. Do we put the subtraction on top and bottom? No, that wouldn't even make sense, because then that would be positive. We multiply it straight across. I multiply it to the top. So I highly recommend thinking of this as, rewriting this as t minus 1. It's just for harder problems I'm showing you. Distribute -1. So we have negative t minus 1 all over t. And now haven't I distributed my negative? So now don't I just combine like terms on top? So you've got to keep in mind if you did distribute the negative or if you did not. Because that's where people mess up. So now you say, I've already distributed the negative, so now it's just technically addition, combine like terms. T minus t is gone. -1 minus 1. -2 all over t. Do not miss subtraction, because that's the one you will miss if you end up missing one. Okay, look at number 5. This is also a a red flag problem. Here's why. People will say that these are the common denominator. They're not even ordered in the same order. To know, you've got to reorder them in the same order. Let's put this in standard form. I rewrite my work nice and pretty every time to make sure that I don't miss anything. Isn't that negative n plus 1? Plus 1 over n minus 1. Okay, now is this considered factored? No, because we can't have a negative in front. So what we're really looking at, I'm showing my work so I don't get confused. I pull out a negative 1, divide by negative 1, divide by negative 1. So then don't I have n minus 1 here? Then plus 1 over n minus 1. There's two ways to finish the problem. You could either get a common denominator, or can't I say this is actually, I'm going to scroll up real quick, isn't n divided by negative 1 negative n? So really, this piece is the same thing as negative n over n minus 1 plus 1 over n minus 1, and don't I have a common denominator? So now I can combine my numerators. So what we have here is negative n plus 1 on top, and on bottom n minus 1. Once again, in your head you should say, this is my answer, but now I need to simplify my answer. We simplify by factoring it out and then dividing out exact factors. What should I factor out on the top? So then left is n minus 1. You're right, we'll pull out a negative 1 on top, so then left is n minus 1. And on bottom we have n minus 1. So what's my final answer here? Yep, negative 1. We're going quick. That's good, because once we get to the harder ones, you're going to want to go slower. And it was the opposite. First hour on accident. Okay, let's do this one. Okay, now understand, people think that you can get a common denominator by like timesing, so watch. People will say, oh, this is n minus 4. I can make this n minus 4 by timesing by negative 1. But that would be negative n minus 4. Still not the same. And then you say, oh, I'm just going to add in a negative here. And that doesn't work that way. You only can fix a denominator by multiplication. Everybody, like multiplying the right thing here. So, there's no way to make these the same besides literally saying my least common denominator. This one has n minus 4. And this one has m plus 4. That's my least common denominator. Does everybody understand? We're going to have to multiply out our tops, but not our bottoms, because we're just trying to get a common denominator. And then our final step in the end is to factor it, so let's not multiply out the denominator. So we're going to multiply this one by m plus 4 over m plus 4. It is an actual requirement, I'm telling you, if you have two terms, you need to put parentheses. You will mess up if you forget that, most likely. Then over here, we're multiplying by m minus 4 and m minus 4. Oh, two terms means I need parentheses and parentheses. Okay, next rule. I even said this first hour and then people were still doing it. Everybody listen. You absolutely have to multiply out your top, your numerator, and then multiply out your numerator and combine like terms before you simplify. Because guess what happens? Let me show you. Let's start multiplying this out. I'll show you where people mess up. So now we're going to multiply out the top. We already know the bottom's good to go. It is the same. But to combine things on top, we need to know what we have. M times 1. M times negative m. 4 times 1. 4 times negative m. Let's combine like terms right there, and then I'll write over the common denominator. So we have negative m squared, don't we? And then m minus 4m, isn't that? And notice I always cross things out so I don't miss anything. And that was all over m plus 4 times m minus 4. So I just took care of this piece. Now I'm going to come over here. There's many ways to do this. I'm going to just focus right here, and then I'll distribute in my negative later. Negative 2m times m. Negative 2m times negative 4. Yep, and then 1 times m. 1 times negative 4. Combine like terms. So don't I have negative 2m squared plus 9m minus 4? And then don't make the error of saying, okay, don't forget, this is subtract all this stuff. Subtract all of this stuff. So now if I take and multiply in -1, right here I'm going to have plus 2m squared, aren't I? Minus 9m plus 4. And that's all over, I'll even write it in the same order, m plus 4 and m minus 4. Now look at it. This is where people mess up. So this is what happens next. Listen, because even though I said this first hour, people kept doing it. They say, okay, so now I need to factor it and divide things out. Well, if you factor this, you're going to end up back here. And then you're going to divide these out. Isn't that what you originally put in? You cannot factor and simplify with addition and subtraction until you have combined your numerators on top. Simplification with addition and subtraction is the last step. You have to combine everything first. Does that make sense? That's different than multiplication and division, isn't it? Okay, here we go. Negative m squared plus 2m squared is how many m squared? M squared, negative 3m minus 9m. Minus 12m's, plus 4 plus 8, and that's all over m plus 4 times m minus 4. Now because you've combined all like terms, it would be appropriate to say that's my answer. Does my answer simplify? So let's see if the top factors. Because if it does, things might divide out. Well, multiplies to be 8 and adds up to be negative 12. 1 times 8, 4 times 2. Do any of those add up to be negative 12? No. So my quadratic does not factor. That means nothing will divide out because there's not factors that would divide out. So boom, 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 I'm done. So it's not necessarily hard. It's just easy to make one sign error, and that just throws the whole thing down the turtlet. So you gotta be really careful. Are you guys feeling okay about these? Yes, good. Okay, number 7. Do you feel like you could try it by yourself? Okay, go for it. Quick. Were you all able to get here by now? We should have been able to. Then you'd say, okay, I better reorder this top to be in standard form, negative 3y squared plus 16 over 8y. Then I highly recommend, if there's a negative in front, it's really considered not factored. So let's factor out negative 1, divide by negative 1, divide by negative 1. So then left is 3y squared minus 16, isn't it? All over 8y. Then you'd say, does my quadratic factor? That quadratic happens to not factor, right? So we know nothing more will divide out. So there is my final answer. Multiply by the least common denominator. So 8 times 8, 16. Y times y, 3y squared. So then we had 16 over 8y minus 3y squared over 8y. So then we combined it. Yeah. I highly recommend it, yes. I highly recommend it. Hey, everybody, try number 8. Go for it. What'd you multiply here by? 4x over 4x. What'd you multiply this by? Now, wouldn't we go 16x squared over 12x? Minus 9 over 12x, am I right? So look, my denominators really are the same. So now I can combine top, 16x squared minus 9 over 12x. What's my next step? That's my answer. Does my answer simplify? We better check, right? Yeah. Yep, awesome. So you said factor the quadratic. What does this quadratic factor to be? 2 perfect squares. 4x plus 3 and 4x minus 3, everyone. Right? You would have forgot that. You would have done what multiplies to be a times c, adds up to be b. You would have dropped and break. You would have ended up where I ended up. That's that over 12x. Now, nothing ended up dividing out in this problem, but now I know for sure because I factored it. So this would be my final answer, which, yes, is the same as this. But this one, just nothing happened to divide out. So we would have lucked out if we would have put this. Now, if you do this, then I'm going to say they really know what they're doing. They're checking. They didn't just luck out. Questions? It's not really too bad, right? So far? Okay, try number 9. Ready, set, go. Did you get this? Why did I not write out the quadratic factors? Because it doesn't factor, so I know nothing divides out. We're all able to get the correct answer. Okay, good news. That is good news. Hey, I can give you like a couple minutes to do some more of the easy ones. I would flip to the back, do as many as possible in section 20 through 28, and then I would do 33 as well. Go as quick as possible so we can get to the more advanced ones. Sorry. Okay, because I know exactly where the people that are making errors what they're doing, and I wish I would have seen this first hour. So everybody, least common denominator. This one has an x. This is x minus 1. There's no way to make an x and x minus 1. You all understand that? So in my denominator, I'm going to have an x. I have an m, so I'm going to need an m. I have an x minus 1. I'm going to need an x minus 1. There's my least common denominator. So what does this one need to make it that? M and... Okay, m and an x minus 1. And then right here, what do we need? So let me show you, the people that are making more errors are doing this. This is what's happening. They're going like this. Okay, so m, this is still good. M times m, isn't that m squared? So I'm going to rewrite this as m squared x minus 1. This is what I do not recommend doing. I do not recommend going like this. M squared x minus 1 plus 4x all over mx, and then x minus 1. Here's why. Because then you're way more prone to start doing things like dividing those out. Do you see what I'm saying? Do not put them together. You're less likely to make errors. If instead, because you have to remember before I divide anything out, I've got to multiply this out and combine like terms. I don't recommend doing that. Instead, leave them separated. M squared times x is m squared x. M squared times 1, negative 1, so minus m squared. Then that's all over xm, x minus 1. Now I'm going to multiply this together, so plus 4x over xm, x minus 1. And now combine the tops. Does that help me for those of you that are doing that, kind of see why it's maybe a better idea to not? Okay, sweet. So now combine like terms. M squared x, any other m squared x's? So we have an m squared x minus m squared plus 4x. And then that's all over xm, x minus 1. Now look at the top. Is there anything in common we could factor out? No. Look, m, no m. X, no x. There's nothing we can do here. So we're not going to simplify. Yeah, but what's the point of doing it, right? Okay. Questions? Okay, keep doing some in that section for a teeny bit more time, but not much more time. On 20 through 28 and 33. So this will be on to the back. The last page is like more of the honors level we should be at. But this is not, this T means this is the teacher example I'm going to do. And then, yeah. So I'm not going to be doing a ton off that worksheet, a few here and there, but I don't want to take away your examples. Because honestly, these just come with practice. If you don't have enough practice, you won't be able to do it. So everybody, look at this one. You don't need to take notes, just look. So first of all, looking at this one, for example, isn't my denominator already the same? Yes. So the good news is, can't I just say, okay, I have the same denominator, I can just combine my numerator. Yes. So we have 2x plus 3 over 2x squared minus 7x minus 15, right? Yes. That's my answer. Now you check. Does my answer simplify? To know, we've got to factor it. So let's factor the bottom. What multiplies to be a times c and adds up to be b. Isn't that my two factors? I've got a long factor, drop and break. So very quickly, 2x squared minus 10x plus 3x minus 15. Factor by grouping. So then factor out a 3, x minus 5. Don't I pull out x minus 5? And then left is 2x plus 3. I highly recommend going and saying, so this became 2x plus 3 over 2x plus 3 times x minus 5. You say, that's my answer. Does my answer simplify?
Yes.
Those divide out. Should I put on the test x minus 5?
No.
No, because then I forgot a 1, didn't I? 1 over x minus 5. Okay, good. I think you guys aren't going to make little errors like that I've seen in the past. Okay, you guys try this one. Go for it. This one's not on the worksheet. Once again, I'm trying to not take any off the worksheet because I really feel like you need them. You need them at home. Just do what I say. You should have got 1 over 3x minus 1 if you've done this correctly. Okay, good. Let's move on. Next one. Hey, looking at this one. Once again, a lot of students mess it up. So how should I rewrite this? 3x over x minus 5 plus 1 over negative x plus 5. Isn't that what I'm really looking at here? So I'm really looking at 3x, x minus 5, and then plus 1 over negative 1, x minus 5, aren't I? Now, couldn't I, because I pulled out a negative here, everybody good, couldn't I take 1 divided by negative 1?
Yes.
So I'm really looking at 3x over x minus 5 minus 1 over x minus 5, because 1 divided by negative 1 is negative 1. So isn't it just 3x minus 1 over x minus 5? Yeah?
Yep.
Okay, sweet. You guys, I'm doing this for a reason, because really people mess them up. Try it real quick. This one should be pretty quick, just like the other one. But once again, if you see it once, that's not going to be enough for you to not miss it every time. Did everybody get that? Sweet, let's move on then. I believe you. Hey, look at this one. A little bit more advanced. So, watching very carefully. This one tricks people. This is, what is this the same thing as? Which is really, now so that I don't get confused, I'm going to erase this and rewrite that here. Negative 1 and x minus 3, right? So then, from there, careful. There's many ways to do this, but isn't this minusing a negative technically? Because can I take this negative and put it out front here? So won't that become plus plus? So really, now can't I just combine like terms? Common denominator, don't we have that? So then 2x squared plus 1x squared is 3x squared. Negative 4x minus 3x minus 7x. Negative 1 plus 4 plus 3, and that's all over x minus 3. Check if it factors. What multiplies to be 9 adds up to be negative 7. 1 times 9, 3 times 3. Nothing. So we're done. That's what I tried to factor. But, well, you could, and then see if there's, and then you could divide things out if there was something, but these don't factor. Oh, this one might. Yeah, there's many ways to do this. So I see what you're saying. You could have divided out, and then you would have had to get a common denominator and simplify. It would have, yeah. Okay, try this one. Go for it. Once again, I'm giving you these because I've seen people miss them so many times. Seeing it once again, really is not enough. You've got to try it at least once by yourself. So try it. Were you able to everybody get an answer? Shout it out. Did everybody get that? If so, we'll move on. So what multiplies to be 40, oh, we better check, and adds up, what multiplies to be negative 40 and adds up to be 3. Nothing. Okay, so luckily we should check though. Okay, cool. Okay, everybody, watch this example. A lot of people do not know how to figure out what the least common denominator is on this one. What is my least common denominator? How can I make 8 or 2 by multiplication? Not quite. Good try. No, I'm just making a point here, though. We multiply to get a common denominator. We're not going to want to do that. What? Anyone else? Yes. Uh-oh. We assumed that it didn't factor, didn't we? Shame on us. Thank heavens for Alyssa. Okay, here we go. We better quickly factor this, because what if it happened to divide out and we missed it? That would be a tragedy. Quickly, quickly, go. You guys factor it. You're way quicker than watching me do it. So the top actually did factor, you said, to be what? Times? Oh, heavens to Betsy. That would have been a tragic mistake on the test if we wouldn't have done that. Good save. Good job, good job. So now we'd say those divide out. So our answer is 2x plus 5. See, I knew there was a reason I put it up there. Sweet. Next one, least common denominator. Yes, 8x squared. Does everybody understand why? Here's how I can really think about it too. Write this out in factored form. So don't we have 4x technically? And then isn't 8 4 times 2xx? 4 times 2x, I mean. So this has 2 x's, so this one needs 2 x's, doesn't it? This one has a 4, this one has a 4. We're good with 4s, but this one needs a 2. So this one needs a 2, and that's it. Isn't my least common denominator, we said 8x squared. How am I going to make this 8x squared? Multiply by 2 over 2, multiply by x over x. I need to multiply this out, so we have 6 over 8x squared plus 5x over 8x squared, and now combine your tops. So 5x plus 6 over 8x squared. Nothing simplified, right? Do this one on your homework. Number 1 on the second page, like the hard page. If you've done this right, you should have got. Or more accurately, I guess technically, same thing though. I would accept either answer, yes. Everybody, hope you got that.
Wait.
No, I did not. So yes. Isn't our least common denominator 20x squared? So then we multiply by 5 over 5. We multiply by 4x over 4x. So then on top, 30 over 20x squared plus 8x over 20x squared. Combine like terms on top, factor it out. Perfect. Okay. Okay, look at this one. What's my least common denominator here? Okay, so we have a 12. Isn't that 4 times 3? A squared b, and then this is 5 times 3, ab squared. Okay, so we need a 4, don't we? Everybody. We need a 3. This one, we need a 3, don't we? Even though they already have a 3, but we definitely need a 3 in our least common denominator then. Then we need an a squared, looks like, and we need a b squared. And we need a 5 from this piece. So 5 times 4 times 3, 60. So 60 a squared b squared is my least common denominator. So what do I need to do to make 12 60? Multiply by 5. So 5, what else do I need? Needs to be b squared, so multiply by 5b over 5b. We need this to be 60. It has a 5, a 3. Don't we need a 4? So we'll multiply by 4 and 4, and then a, right? To make it a squared. So now multiply across. You have 25b over 60 a squared b squared minus 16a over 60 a squared b squareds. And now you can combine your top. So you have 25b minus 16 over 60. Sorry, I'm going too fast. 60 a squared b squared. Nothing factors on top. So we're done. Okay. Here we go. Watching this one. What should I multiply this one by? Y plus 3 over y plus 3, right? And then I need parentheses. What do I need here? So we've already done some like this. So then careful though, once again, let's do this one in our head. Y squared plus 2y plus 3y. And then plus 6. And that's all over. Is anyone going to be mad if I write CD as in common denominator? So I don't have to rewrite it out again for right now. Then okay, let's not distribute in the negative quite yet, maybe. So then don't we have y squared? Minus 5y minus 4y. Plus 20. All over common denominator, and isn't it subtract? So I need to go like this, don't I? So then really we have y squared plus 5y plus 6 over common denominator minus y squared plus 9y minus 20 over common denominator. Now can I combine my numerators? Okay. Don't forget what the common denominator was, because I'm going to go away. Those go away. 5y plus 9y. 14y minus 14 all over. We're almost to our answer. We need to write it down. Y plus 3 and y minus 5. Y plus 3, y minus 5. You say, that's my answer. Does my answer simplify? Shouldn't I pull out a 14? Y minus 1 all over y plus 3, y minus 5. So nothing simplified. Okay, okay, looking at this one, sorry. Do you guys want to try one like that by yourselves, or is that so easy that you're ready to move on? Okay, look right here. A lot of people want to just multiply by a squared minus 4, a squared minus 4, a minus 2, a minus 2. That's a tragic mistake because that's not the least common denominator. So to know the least common denominator, we need to have this factor, don't we? So we have a plus 5 over a minus 2 minus 5a plus 18. And then what does that bottom factor to be? All right, so now what's our real least common denominator? A minus 2, a plus 2. So don't we only need to fix this one? Did you see how fixing both would have been a sad story? So multiply by a plus 2, multiply by a plus 2, and now we can go ahead and multiply this out. A squared plus 7a's plus 10, all over common denominator, minus 5a. Uh-oh, it's minus. So would anyone be mad if I just go ahead and distribute that right now? Minus 18 over common denominator. Now can I combine my numerator? A squared plus 2a minus 8 all over, now I need to write it, a plus 2, a minus 2. You say, that's my answer. But does my answer simplify? That's okay, I'll fix it. Good point. Okay, so I'll change that with a color. There we go. So now we would say does the top factor, well, multiplies to be negative 8 and adds up to be 2. Negative 4, positive 4, is it negative? Okay, positive 4 and negative 2, right? Can I quick factor? So the top factor is to be a plus 4, a minus 2, and on bottom we had a plus 2, a minus 2. So now, isn't our final answer just going to be that? Okay, cool. What I want you to do is number 3 and 4 on the worksheet. Go. I'm going to do number 10 on your worksheet. So looking at this one, when adding and subtracting 3 things, all 3 things need to have a common denominator. Now, to know the least common denominator, each piece needs to be factored. So on number 10, you should rewrite this part as x plus 7, x minus 7. So I'm going to erase that so I don't have to rewrite it again. So x plus 7, x minus 7. So isn't my least common denominator x plus 7, x minus 7? So what does this one need? X plus 7. I want to multiply by x plus 7 over x plus 7. If you have 2 terms, you better use parentheses. This one needs an x minus 7, doesn't it? Now look at all your denominators. Boom, boom, boom. Aren't they the same? Okay, good. Now before you do anything, multiply out your tops and combine like terms. So I would even say, I put little brackets so I don't forget where I'm at. So we have 7x minus 49 over common denominator. Then right here, I'm going to distribute negative x through. Negative x times x, negative x squared, minus 7x over common denominator, plus 2x over, isn't that already the common denominator? Now, shouldn't I combine my numerators at this point? So we have negative x squared, no other x squared, plus 7x minus 7x. Then we have a plus 2x. and then minus 49. And now I will write all over x minus 7, x plus 7. And you say, that's my answer, but does my answer simplify? So we would pull out a negative 1 for sure. X squared, because then we can quick factor too. If it does factor, x squared minus 2x plus 49 all over x minus 7x plus 7. And then you'd say, what multiplies to be 49 and adds up to be negative 2? 7 times 7, 1 times 49, nothing. So we're done. Okay, look at number 12. This one gets people. Here's why. First of all, would it be appropriate to take negative 2 and go, oh, that's the negative 2, that's the negative 2? You're right. No, absolutely not. That's breaking the most forbidden of all forbidden rules, isn't it? You can't just square that, can you? You can't just negative square that and negative square that. Do you guys all understand that that is breaking the forbidden rule? Okay, so then you should say to yourself, though, what am I looking at here? Well, we can't have a negative exponent. It's not considered simplified. How do we fix that? Flip the base over the fractions. Isn't that how you fix negative exponents? Yeah, you do. X to the negative 2 is the same thing as flip the base, 1 over x squared. So once again, how do we fix a negative exponent? Flip it over the fraction, so that'll be a minus b squared on bottom. So on top, we had 1 over a minus b squared. Does everybody see how I just rewrote this first piece? I've not done anything. I've just rewritten it in a prettier format. So then minus, same thing here. This has got to flip down. 1 over a plus b squared. Now, aren't we just dealing with fractions, just like adding and subtracting fractions, just like before? Okay. So now what you would do is factor out your bottoms. So we have 1 over a minus b times a minus b. Because by definition, something squared means it multiplied to itself twice. Minus 1 over a plus b times a plus b. So the least common denominator is a minus b, a minus b, a plus b, a plus b. So we're going to have to multiply by, let's change colors. Right here. Yeah, but let's write it out, because when we do that, we actually write it out, don't we? A plus b times a plus b, a plus b times a plus b. Everybody with me? Over here, we're going to need an a minus b, a minus b, a minus b, a minus b. Then remember, from there, you've got to distribute out your numerators. So look, 1 times all that stuff is just all that stuff. So let's just distribute all that stuff. A squared plus AB plus AB is how many ABs? Plus 2 ABs. And then plus B times B. Plus B squared. And that's all over the common denominator. Is that bugging people how I'm doing that? Because it's 10 times quicker, so too bad. And then we have negative 1 times all that stuff. See, whenever we're multiplying 3 things together, I multiply these 2 together and then multiply in the third thing. So won't this be a squared minus AB minus AB, so minus 2 ABs, plus, so one distribution of a negative here wrong, and it's all downhill. You're seeing what I'm saying? A negative times a negative is a positive b squared. Now, isn't it negative 1 times all that stuff now? Look, negative 1 times all that stuff. So what we're really dealing with is negative a squared plus 2ab's minus b squareds all over common denominator. And now we can combine our numerator. So a squared minus a squared is gone. 2ab's plus 2ab's. 4ab's, b squared minus b squared. And that's all over a minus b squared times a plus b squared. Isn't that what our common denominator is? You could write it out. You could write it like this too, because I knew nothing divided out, so I'm just writing it. Same thing as writing it out, right? This is fine. Well, this is fine. Okay, go to number 1 on the back page, everybody. No, the next one, number 1. Okay, here we go. So looking at this one, this is an advanced math class, and I have to ensure that your algebra is good for calculus, so that's why we're doing advanced problems. There we go. So looking at this one, isn't it division and subtraction? What should we do first? Yeah, you should do the division part first, and you're right. Dividing fractions is easy as pie. Flip the second end. Multiply. So what we're really looking at is times x squared minus 1 over x plus 5. I think we messed up first hour on this one, so we're going to go a little slower. Does everyone agree that this is what I'm looking at? Same thing. So I'm just going to erase this. I would rewrite it. I'm trying to go quick. Once again, multiplication needs to be simplified before addition and subtraction. Think of order of operations. So now simplifying multiplication, don't we just factor it all out and divide out exact factors? Okay, so right here, let's factor out a 2. And then left is x plus 5. Doesn't this piece factor to be x minus 1, x plus 1? Is anyone lost on what I'm doing? And then on bottom, don't I just have x minus 1 times x plus 5? And now we still have technically this, minus 4 over x plus 1. Well, before we do the subtraction part, we should simplify our multiplication part. So these divide out. These divide out. So left is 2, x plus 1 over 1 minus 4 over x plus 1. So now we would go ahead and subtract them. So you're right, get a common denominator. So I'm going to multiply by x plus 1 over x plus 1. Let's reorder this on top. Let's put the 2 in front. So we have 2 times x plus 1 times x plus 1 all over x plus 1. Don't divide them out, because then you're re-dividing out what you just put in. And now we need to multiply out our tops. So let's go ahead and distribute this part first. So won't that be 2 times x squared plus 2x plus 1? You can, but if I asked you to multiply that out, how would you rewrite it to multiply it out? Like this, because you wouldn't break the forbidden rule. So don't we need to multiply out our numerators? So then we really have in this piece, so that was all over x plus 1 minus 4 over x plus 1. Before you put them together, once again, multiply in 2. So we have 2x squared plus 4x plus 2 over x plus 1, and then minus 4 over x plus 1. And now we can combine our numerators. So that would give us 2x squared plus 4x minus 2 all over x plus 1. It is 4x. Okay, now that's my answer. Does my answer simplify? Let's factor out a 2. Left is x squared plus 2x minus 1, isn't it? All over x plus 1. And then you say to yourself, okay, does that quadratic factor? So it multiplies to be negative 1 and adds up to be 2. But that would be positive 1, wouldn't it? So even if, so that means what? It doesn't factor. So luckily we're done. I don't know how I missed that one on my key. Because that was right. Yep. I promise, even I did it first hour, we got the same answer. I thought I did it wrong first hour. We went slow. I didn't mess up. We didn't mess up, just barely, I promise. Okay, Okay, here we go. So my key, I went too fast when I played it by myself. Here we go. Look at number 10. Okay, there is easy, there are right ways, there are long ways. So as long as your algebra works out, you're gonna get the right answer. There's an easy way and a hard way to do this. What I would do first is combine the inside here to have one thing, like one fraction. You could distribute x plus y through here and here, then get a common denominator, but that would just take longer. Your algebra, if it's nice and sound, it'll come out right. So do you see why I might want to put these together? Because then we're multiplying maybe a little less. Okay, so don't we need a common denominator? So focusing on the inside, let's get a common denominator. So there are times when I'll start doing it and I'll be like, oh, I just did it probably the long way. Okay, common denominator here. Y over y, x over x. So now doesn't this piece, I would rewrite what I have. We have x plus y times what's inside? Y minus x over, do you see why I got y minus x? Yep, over yx. Okay, so that was the top. Let's do that same thing with the bottom. So I'm going to focus right here, multiply by y over y, x over x. So now on bottom, I still have x minus y times y plus x over, yep. So now from here, I would continue to simplify this piece now. So, isn't it just multiplying straight across? Yeah. With multiplication, we don't have to have a common denominator. So this is going to be, I'm going to leave it factored, because remember with multiplication, isn't it almost easier to leave it factored? So multiplying straight across here, I have x plus y times y minus x all over xy or yx, however you want to write it. Then down here, I'm going to multiply straight across, once again leaving them factored, because y put them together, and then have to refactor them. Multiplication, can we leave them factored? You get what I'm saying? So on bottom, I have x minus y times y plus x, and that's all over yx. Now guys, question for you. Dividing fractions is easy as pi, flip the second and multiply. Can't I do that here? A fraction divided by one fraction. So here we go, let's do it. Flip the second. Doesn't yx come on top? And what's on bottom? X minus y and y plus x. Is everybody with me? I can't tell. Half of you are just kind of not really. Can't tell. Well, sure means no. So. Maybe. So we're here. I don't know. Now, can't I divide out exact factors with multiplication? Yes. So we have this and this that divide out? Yep. Careful, very careful. With addition, we can reorder this. So are they the same? But careful. Ooh, really careful. Don't just divide those out. You got to think. With subtraction, we better put them in the same order, don't you think? So let's rewrite this top as negative x plus y. So this is what we're really dealing with. Negative x plus y over x minus y. Now factor it and simplify. So pull out negative 1 on top. Left is x minus y. On bottom, x minus y. So my final answer is? Awesome, negative 1. Guys, did you see how the algebra was long and hard? That's how you're going to get good at algebra, is doing problems like this. This is how you're going to make sure that when you get to calculus, you don't fail because your algebra is not good enough. This is the level you have to be able to think on. I know you can do it. They did it last year. I know you can do it. It is going to take hard work and not making errors and then coming to get help if need be. But I know you can do hard things. Hey, have fun. At the end of the lesson, we made it through all of it. In the nick of time.